Watch these two boxes. Same distance, same duration. Exactly 1 second, both of them. But one of them feels dead, mechanical, like a robot arm. The other one feels alive. Here's the strange part. The difference isn't the distance, and it isn't the time. It's something most Flutter developers use every single day, without actually understanding what it's doing. 3 ideas: AnimationController, Tween, Curve. By the end of this video, you won't just know how to use them, you'll know exactly what's happening underneath, frame by frame. Let's open the hood. First, let's fix a misunderstanding. In Flutter, an animation is not a moving picture. It's not the box sliding across your screen. An animation is just a value that changes over time. That's it. That's the whole definition. Most of the time, that value is a simple number between 0.0 and 1.0. Nothing more than a percentage. How far along we are, from start to finish. The moving box, the fading opacity, the growing circle, none of that is the animation itself. Those are just things we build by reacting to that changing number. So the real question becomes, who is responsible for changing that number frame after frame? That's our next character. Meet the Animation Controller. Think of it as the stage manager of your animation, the one person backstage with a stopwatch making sure everything moves in time. Setting one up is simple. You create an animation controller, give it a duration, let's say 1 second, and hand it something called a vsync, which basically just means stay in sync with this screen's refresh. You're telling Flutter one simple thing. Take 1 full second and count from 0.0 to 1.0 for me. Call forward on it and it starts counting up. Call reverse and it counts back down. That's it. At its core, the controller is just a number generator on a timer. But here's the part that trips people up. How does it know when to update that number? It's not sitting on some ordinary software timer ticking away on its own schedule. It's tied to something much more precise. That vsync you passed in isn't decoration. It's the controller plugging itself into your device's ticker. A ticker fires once every time your screen is about to draw a new frame. 60 times a second on most phones, maybe 120 on newer ones. Every tick, the controller asks one question. How much time has passed since I started compared to my total duration? And updates its 0.0 to 1.0 value accordingly. This is why your animations stay buttery smooth, even if the frame rate changes. The controller isn't counting frames, it's tracking real elapsed time and syncing to the screen's own refresh rhythm. No wasted frames, no drawing when nothing's actually going to be seen. So now we have a stage manager ticking away, producing a clean number from 0.0 to 1.0. But a plain percentage isn't very useful on its own. We don't want 0.6. We want a box at x equals 240 pixels, or a color that's 60% of the way from blue to red. That translation job belongs to our next character. Meet the Tween, the translator we've been waiting for. A tween doesn't know anything about time. It doesn't tick. It doesn't animate anything by itself. All it knows is 2 things: a start value and an end value. Say we want something that starts at 0 and ends at 300. Feed it a progress value, say 0.5, and it hands you back the number exactly halfway between 0 and 300, 150. That's the entire job of a tween. Given how far along, calculate what's the actual value right now. It's pure math, no clock involved. And Tween isn't locked to plain numbers. Flutter ships with a color tween, which blends between 2 colors. An offset tween, which interpolates positions. A rectangle tween, which interpolates size and position at once. You can even tween your own custom objects, as long as you tell Flutter how to blend between 2 of them. Under the hood, every single one of these relies on the same underlying idea, commonly called LERP, short for linear interpolation. Linear is the key word here. Left on its own, a tween always moves at a perfectly constant rate. Which brings us to the missing piece. Because constant rate is exactly what made our very first robotic box feel so lifeless. This is a curve, and it's the single most important concept for making animation feel right. A curve is a function. You give it a time value from 0.0 to 1.0, and it gives you back a progress value, also usually between 0.0 and 1.0. But it doesn't have to be a straight line. Look at this graph. The straight diagonal line, that's the curve called linear. Equal time, equal progress, every step of the way. That's our robotic box from the very beginning. Now watch this S-shaped curve. Flutter calls it ease in, out. At the start, time passes, but progress barely moves. The object is building up speed. In the middle, it's moving fast, covering a lot of progress in a little time. And near the end, it slows down again, easing into its final position. This one right here, that shoots past 1.0 before settling back, that's a curve called elastic out. It overshoots the target and springs back, like letting go of a stretched rubber band. None of these curves know or care about pixels, colors, or duration. A curve is purely about pacing, remapping linear time into eased progress. It's the director whispering to the actor, "Slow down here. Now go fast. Now settle." So how do we actually apply a curve to our controller's linear ticking? We wrap them together using something called a curved animation. You give it the controller as its parent and the curve you want applied. Think of a curved animation as a lens. The controller keeps ticking linearly underneath. Nothing about time has changed. But every value that passes through this lens gets reshaped by the curve before it comes out the other side. The controller still says 40% of the time has passed. The curved animation says, but only 20% of the visual progress has actually happened because we're still easing in. Now we have all three pieces talking to each other. Let's assemble the whole pipeline. Let's trace one single frame through the entire system, start to finish. Step 1. The screen is about to redraw. The ticker fires. Step 2. The animation controller checks elapsed time and produces a plain linear value, say 0.4. Step 3. That 0.4 passes through the curved animation, which reshapes it according to our ease-in-out curve, coming out the other side as, say, 0.29. Step 4. The tween takes that 0.29 and interpolates it into a real value. If we're animating from x equals 0 to x equals 300, that's roughly x equals 87 pixels. Step 5. That final value is handed to your widget, usually through something called an AnimatedBuilder, which rebuilds just the part of the UI that depends on it. 60 times a second or more, this entire chain runs again. Ticker, controller, curve, tween, rebuild. That's the whole machine. Now that you can see the machine, here's how experienced Flutter developers keep it running cleanly. Always dispose your controller. A ticker keeps firing as long as its controller is alive. Leave it running after your widget is gone and you've got a memory leak quietly ticking away in the background. Inside your widget's own cleanup method, you dispose the controller too. Use the right mix-in. A single ticker mix-in if you've got one controller. A multi-ticker version if your widget is driving more than one. That mix-in is literally what makes the vsync you're passing in valid. Prefer an AnimatedBuilder over managing state yourself. An AnimatedBuilder listens to the animation and rebuilds only its own small subtree, not your entire widget. That's the difference between a smooth 60 frames per second animation and a janky one on a heavier screen. Use status listeners for sequencing. Attaching a status listener tells you when an animation completes, dismisses, or reverses. Perfect for chaining one animation into the next without hard-coding delays. This is also where things like repeating controllers, multi-stage tween sequences, and your own custom curve classes come in. But the mental model never changes. It's always time in, progress out, value out. Let's bring it all the way back. The AnimationController is your stage manager. It just keeps time, producing a clean, linear 0.0 to 1.0 value. The curve is your director. It takes that linear time and reshapes how progress unfolds. Slow starts, fast middles, springy overshoots. The tween is your translator. It takes that reshaped progress and turns it into an actual value your UI can use. A position, a color, a size. 3 simple, separate jobs. Combine them and you get that box from the very start of this video. The one that didn't just move, but felt like it had weight and intention behind it. Now you know exactly why.